So our discussion of the Condorcet-Urey theorem would tend to have a very positive kind of like a outlook, right, in terms of voting. So, for example, it says that under the conditions that we discussed, so sincerity and simultaneous votings, basically a group of people would do a much better job than an individual when it comes to deciding which particular action to take, right? So this you can actually recall that there is only a probability Q that an individual would do the right thing in terms of voting. But now if you add more and more voters, then the probability tends to reach to one that the individuals, the group of people would actually get to the right outcome, right? Would choose the right thing. However, there were two crucial assumptions made. One regarding that the voters are actually voting sincerely, and the second one that the voters are actually voting at the same time, right? So it's worth thinking about how robust are the findings of the Condorcet-Urey theorem once you relax those assumptions, right? So what we are going to do is we are going to relax the assumptions one by one. So that means that we are going to, for example, still assume that voters are voting simultaneously, but we might want to relook at this assumption that the voters are voting sincerely, right? So what does it mean that voters are voting sincerely? It means that each is choosing the alternative that he or she believes to be the best given the information available. Now, at first sight, this might seem to be a very innocuous assumption, right? Because the voters all care about reaching the correct outcome, right? And there's no conflict of interest between the voters. Then in that case, what is the incentive of the voters to kind of like not vote sincerely, right? That might be a natural question to come. However, we'll see through the means of an example that actually it might turn out that even if the voters are kind of trying to do the best for the group, that they may end up actually choosing to vote insincerely, right? So what that means is that they might tend to end up voting for the alternative that they might consider to be the worst, even though the goal is to maximize the probability that the group as a whole selects the best alternative. So this is a very counterintuitive kind of like explanation, right? So let's look at an example to see how such a scenario might emerge. So imagine that you have a experimenter, right, who announces that there is an urn with 10 marbles that is going to be placed in the front of a room, right? So only the outside of the marble, the outside of the urn is visible, not what is the color of the marbles inside. So we don't know what is the type of the urn. So there is a 50% chance that the urn is going to contain 10 white marbles, in which case we are going to call this as a pure urn. And there is also a 50% chance that it contains 9 green marbles and 1 white marble, in which case we are going to call it as a mixed urn, right? So the experimenter is going to ask a group of 3 people to collectively guess what kind of urn it is, right? Is it a pure urn or is it a mixed urn? So how is the experiment going to proceed? So first, each of the 3 people are allowed to come in and draw one marble from the urn, look at it, note down the color without showing it to the other two, and then just replace it with the urn. So notice that in contrast to the information cascades, there is no kind of like communication from any of the person to the public about what is the color or what is its guess, right? They're just kind of like silently going, noting down what is the color of the marble that they have drawn. They do not show it to the other two, and then they place it to the urn, right? And then the 3 people are asked to simultaneously cast votes without communicating it, each guessing what type of urn they think it is, right? So basically, the role of kind of like drawing this marble is acting as if it's a private signal, if you think about it. And because these are like independent draws, so it's independent private signal. Now, how is the voting going to play out? So if the majority of the votes are for the correct type of urn, then all 3 people are going to win a monetary prize. However, if the majority of votes are for the wrong type of urn, then nobody gets anything, right? So notice that even if you as a person get the correct answer, you're not going to win anything if the majority gets the wrong answer, right? So this is how all the incentives are kind of aligned in the sense that everybody wants the same thing, which is for the majority to get the right answer, right? So what is the color of the marble here? That is the private signal, right? And this signal cannot be communicated. So we can now think about how we are framing this in terms of the Condorcet-Urey theorem. And the group decision has to be reached by majority vote. So this is one thing that is kind of like there, it was there. But remember, in the Condorcet case, we had this assumption that each person is going to vote actually sincerely, right? Here, we actually want to kind of like question that assumption that in this scenario, for example, would it be an equilibrium for everyone to vote simultaneously, right? So that is the question that we want to kind of like think about, okay? So let's put in a bit more structure. So suppose that you are one of those voters, right? And you draw a white marble, right? So you can do the math, and you can in fact show that in this case, this is more likely to have come from a pure urn, right? Remember the numbers. So the pure urn contains 10 white marbles, and a mixed urn contains only one white marble and nine green marbles, right? So if you pick up um, a white marble, then you can do this using Bayes rule as well, and you can show that it is much more likely that you think that this urn is actually pure versus mixed, right? On the other hand, if you draw a green marble, then you know for certain that this urn is mixed, right? Why? Because the pure urn does not contain any green marble, only the mixed urn contains a green marble. So if you draw a green marble, then you know for sure it's mixed, and then you should definitely vote for uh, mixed, right? The question is, in the case that you had drawn a white marble, in that case, should you vote for pure or for mixed, right? Now, if you were to vote sincerely, then the answer is clear, right? You should vote pure if you draw white, and you should vote mixed if you draw a green marble, right? But the question is, should you vote sincerely though or not, right? So here, notice the question is like, is everybody voting sincerely and equilibrium or not, right? So let's think about it. Suppose that you think that the other two people in the group are going to vote sincerely, which means that they are going to vote exactly in this following way, that if they are going to draw white, then they are going to vote pure. And if they are going to draw green, then they are going to vote mixed. The question is, should you follow the same strategy or not, right? Uh, so one question to think about is, in what situation exactly does your vote actually affect the outcome? That is the crucial question, right? If in case your vote does not affect the outcome, then it doesn't really matter what you vote for, right? You could have voted for anything, your payoff would have been the same, right? However, only in the situation in which your vote actually affects the outcome, then only your vote matters, right? Now, if you're in a majority voting of three people, then the only situation where your vote actually matters is that one of the people in question, one of the remaining two, has voted for pure, and the other has voted for remaining, right? So now, if they were voting sincerely, the only case in which one of them has voted for actually mixed is that when they had actually seen the green marbles, right? But if that is the case, then you know for certain that in that case, the urn has to be mixed, right? So the conclusion from this is that whenever your vote actually matters, the urn is mixed, right? And if you know that your two partners are going to actually vote sincerely, then the best way in which you can help the group is to actually by voting mixed, right? So what that suggests is basically that, everybody voting sincerely is not an equilibrium, right? Because you are better off voting always mixed rather than that. Now, does that mean that you should always vote mixed? Well, it depends on what the equilibrium is, right? So calculating the equilibrium in this situation is a bit complicated, right? So it involves notions of mixed strategy and so on, which we are not going to go here. But the main point of this takeaway should be that this assumption that we have made that everybody votes sincerely, that is not necessarily true here in equilibrium, right? So everybody voting true is something that, while good as an assumption, is actually not something that is actually equilibrium in the game theoretic sense. Okay. Now, let's go back and think about the second assumption that we had made. So remember, we had made two assumptions. One is that voters are voting sincerely, and the second one is voters are voting simultaneously. What we did right now is that we relaxed the assumption that voters are voting sincerely, and then we explored the possibility and saw that there are reasons here to kind of like think that that may not be the case. So let's now get back to that world where voters are voting sincerely, but let's remove the assumption that voters are voting simultaneously, right? So now suppose that kind of like voters are voting one by one, right? And you get to actually observe what the voters have voted for. And basically voters voting sincerely means that they are going to basically vote for the alternative that she actually believes to be the best choice. Now, in this case, whenever you have like sequential voting like this, if you think about it, the situation becomes very similar to the information cascades, right? So in fact, you have all the results that we have, and actually the structure is very same. So if you have got voters acting sequentially, then again, you might have a possibility of information cascade. So any two initial votes in favor of X is going to cause a cascade in which everybody will end up going to vote for X as well, regardless of whether X is the correct decision, right? So the fact that there's going to be two initial votes depends on the structure of the problem, which we have made here very similar to the information cascades. More generally, the idea is that there is a good chance that a cascade will eventually develop, right? And the cascades can be wrong, right? In the sense that even if Y is the best alternative, we may have actually ended up with a cascade where X is developing, right? And here, just as with the information cascade situation, increasing the number of voters does not help in stopping the cascade, right? So in condensate theorem, you had the result that If you have a large enough number of people, then you are going to get the right answer with probability 1. We see that if you change the assumptions there by having sequential voting in place of simultaneous voting, then this result no longer holds true, right? So there is no reason to expect that a large crowd of sequential voters is going to get the right answer. So this is it for our discussion of voting. So no, I think the interest on this topic comes from the fact that it's not only basically something that tells you some things about politics, which what people will associate with the word voting, but there is a lot of things that are there that are in the modern economy to kind of like think about, right? So it's there when it comes to jury selection problems. It's there when it comes to deciding the best set of players. It's there in the data economy whenever you are thinking about how to build recommendation systems or how to, for example, think about how to kind of like design blockchain governance, right? So these are, again, some of the new places where you have got the social choice ideas, which were initially developed to think about voting in a political context or in a corporate context, becomes applied more and more to the data economy. So if you want to read more about it, and the discussion in this chapter was based on basically this chapter 23 of this book, Networks, Crowds, and Markets. And as usual, this is available online in the link that is provided before. So that is it for this week. We are going to continue next with some more applications of game theory as we proceed further in the course.